Another aspect of refraction is called dispersion, and this is very commonly seen in prisms. This is called a prism. You can see the triangular shape, and there's all different kinds of shapes. You'll find prisms in cameras, binoculars, and those kind of optical devices. We have an incoming ray here, see, on this side, and we have a refracted ray over here, and if you look close, you should be able to see color. Yeah, there's red, if you look real close, orange, yellow, green, blue, you could even recognize it, indigo and violet are all in there. So a prism will refract all that. And that's a very similar colors to the rainbow, right? Same color. And we talked about frequency earlier in the unit and wavelength based on the electromagnetic spectrum. Red has a longer wavelength than violet, but it has a shorter frequency or a lower frequency than violet. So what that means is red having a lower frequency means it has less waves coming to you in the same amount of time. Violet would have more waves in that same amount of time. So violet is actually a higher energy light. Red has longer wavelengths, however. Another aspect of refraction is something called total internal reflection. So let me show you what that looks like. If you get at a particular angle, I'm going to draw this so you can believe me because I know this is in the dark. So the light came into the prism here. This was the incident ray, and it left over here. It left over here. This is the refracted ray. So what you notice, instead of going through the prism like it did before where it dispersed into color, when light came into the prism from air, it slowed down, so it bent a little bit. Then, because of the angle it's at, it's called total internal reflection. So then it bounced on the internal surface. This became like a mirror. And then when it came to this point, again, you're going now from glass to air, it sped up, so it bends away from the normal, and it left the prism. Now, where do you see this? You actually see this in the formation of the rainbow. We saw the rainbow colors when the light was dispersed, but actually in the sky, water droplets are like little prisms, and the light hits the droplet and it internally reflects, and when it leaves the droplet, it disperses into the colors. And when all that is intensified, you can see Roy G. Biv, or red, orange, yellow, green, blue, indigo, and violet.